Hello, everybody. This video is going to cover scientific notation. Scientific notation is just a way of taking really big numbers or really tiny numbers and writing them in a more condensed format that's easy to do math with. So, for example, numbers in science. Now, I'm going to give you the mathy definition here. This is horrible, but you got to get used to reading these things. So I figured I'd put it up there and I can kind of explain it to you. Here we go. A number written in scientific notation has the form c times 10 to the n, where 1 is less than or equal to c, less than 10, and n is an integer. I know that sounds horrible, but here, if you look at the first part of this, c times 10 to the n, that's what a number would look like that's written in scientific notation, where c is any digit from 1 to 9, and n is an integer. So what you're doing is you're basically multiplying or dividing your big number or your small number by multiples of 10. And this right here tells you what the multiple of 10 is. That's called the order of magnitude, by the way. Order of magnitude. So, I forgot an I there. Okay. So, let me give you an example. I'm going to give you first a number that's in standard form. Standard form. Or it's called expanded form. I'm going to give you the distance from the Earth to the Sun. It is 92,960,000 miles away. If I wanted to write this in scientific notation, first of all, you got to think about where the decimal is, and it's always on the end here. I want to move this decimal to the left, so here's going to be my scientific notation. I want to move it to the left so that the number that's in front of the decimal is something that is in between 1 and 10. It can include 1. Actually, it's just digits 1 through 9. So what I'm going to do is I'm going to move it here. 1, 2, 3, 4, 5, 6. I had to move it 7 places so that the number in front is between 1 and 9. Then what I'm going to do is I'm going to write all the digits, so it's 9, that are not zeros. 9, 2, 9, 6. If I had a 0 in between here, like say this, I would write that 0. I'm going to leave off the trailing zeros. So in other words, these right here. And then I'm going to say, all right, multiplied by 10. And then how many times did I move the decimal over? I moved it 1, 2, 3, 4, 5, 6, 7 places. So 10 to the 7th. So in other words, in scientific notation, here's my number, 9.296 times 10 to the 7th. If I wanted to write that in standard form, I would just take the decimal and move it 7 places to the right, and I would get what the actual number is in standard form or expanded form. So now what I'm going to do is give you one that's really tiny. I'm going to give you the mass of a carbon atom, of one carbon atom. This is really tiny. I hope I can write all these zeros here, right? Here goes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 zeros. This goes out there. And now it's about 2. You know, I actually think it's 1994 or something like that, but let's just say it's about 2. That is a really tiny number. So what we would want to do here is we want to move the decimal this direction so that the number in front of the decimal, again, is 1 through 9, including 9. So 1, 2, 3, 4, 5, 6, 7, 8, or 9. So in other words, I would need to move it so it's right there. Then my scientific notation would be 2 times 10. Now how many places would I have to move it? Here's a little trick when you're doing scientific notation. If there's a leading 0 here, which this one does, you can just count the number of zeros and that's how many places it moved. If you remember, when I was writing them, I counted to 23. So I'm going to write 23. But now, because this is a tiny number, it was actually a negative 23. So that tells you when I have a number like this, 2, and I want to write it in original form, the negative tells me move this thing to the left in the negative direction so that I get my original number back. Okay? I hope that makes sense. Which of the following are in scientific notation? So I have two of them up here. One of them is. Look at it. You just say, oh, it's this one. And you know it's that one because the number out in front. When you look over the one on the left, you have a 10 out in front. And it's supposed to be a 1 to 9. So this one, no. This one, yes. Pretty easy, right? Why don't we try and do one? Here. Write the numbers in scientific notation. So 4,100. And then, wow, what is this? 0.000067. Write those in scientific notation. Pause the video and try it. Okay, hopefully you got 4.1 times 10 to the third. Because the decimals here, I had to move it 3 places to the left. That's why it's to the third. This other one, I have 6.7 times 10 to the negative fifth. Because it's over here, it's a small number, I had to move it to the right. And I had to move it 5 places, so it's the negative fifth. Now, I have numbers that are in scientific notation, and I want you to write them in standard form. Can you do that? Try it. Pause the video. All right, for these, I have here 7.1, and my order of magnitude is 4. So that tells me move the decimal to the right 4 places. So 1, 2, 3, 4. These spots I fill with zeros. So this would be 71,000. This one would be, it's a negative 3, so I'd move it to the left. 1, 2, 3. And fill these spots with zeros. Now, it's a good idea to put a 0 out in front, that leading 0, because it looks better. And we don't miss seeing the decimal point then. Okay?